Welcome. In this video, we are going to look at another question on speed time graphs or velocity time graphs. And the question says, figure 2.5 below shows a velocity time graph of an object moving along a straight road. So we've been given this figure, this diagram, and we have two axes. We have the y-axis, which is for velocity in meters per second. And then we have this axis, which is the x-axis, which represents time in seconds. Now, the first question that we are told to find or to figure out is, what is the total time for the journey? Part B, what is the maximum velocity for the journey? Part C, what is the acceleration of the first part of the journey? And D, calculate the total distance. So these are the questions that we are going to handle. Now, it is very much important to take into consideration, like when are given the graphs such as this one, you need first to know what each axis represents. And from that now, that's when you need to look at the question. So we are told to find, the first part is to find the total time for the whole journey, or to identify, or to answer it, to give the total time of the whole journey. So we have, from the journey is starting from this one, which is the initial position, the initial point, until this point. And the axis that is representing the time is the x-axis, which is this one. So the total time for the whole journey is 50 seconds. So here, solutions, we have A, total time is equal to 50 seconds without even wasting time. Then what is the maximum velocity for the whole journey? We have, so from this point to this point, the object or the car is the object is accelerating. So the highest velocity is actually at this point. This is the initial velocity, which is the starting point. It is just at rest. Then it came to 10. It came to this one as the maximum velocity. So B, the maximum velocity is 10 meters. So this axis is for velocity. So maximum velocity is equal to 10 meters per second. Then see what is the acceleration of for the first part. So we have so from this point to this point, we have this just the dotted lines to show that it's okay. So this is part C. We know that acceleration is given by the change in velocity v minus u over t. Now, since the object is starting from 0 here, the initial velocity, which is u, is 0. Then the final velocity is this one, which is the maximum velocity in this case here. V is equal to 10 meters per second. And the time is 20 seconds. So if we plug in this into this equation, we are going to have this one. We have 10 minus 0 over 20, which will give us 10 over 20. So this is, we're just going to have 0.5. Now the units for acceleration are meters per second squared. So we have this meters per second over this 1 second. So it makes second squared, and these are the units for acceleration, meters per second squared. But here we are going to find the total distance. So for total distance, we can find the total distance by calculating the distance of this. Okay, so we can segment this into, okay, we find the area of this, and this, because distance is equal to area under the shape. Area under the shape of the graph. Under the shape of the graph. So here we have how many? We have 1, 2, 3 shapes. So this one we have one, a triangle. We have this one, A1, A2, A3. So we can find the area of this one, and this one. Then we add them. So the total distance now. So d total distance is equal to total distance is equal to A1 plus A2 plus A3. Now this one we have, for this one it is half. It is a triangle, half times B. Let me just say half BH plus, so this one it is the LB, it is a rectangle, plus half BH. So this one, when we plug in the values, so from this to this, we have, from this point to this point, we have 20. So half times 20 times H is 10 plus LB. So we have the L from this to this. So 20, 40 minus 20, we have 20 times the breadth, which is, in this case, is 10, or width. Then plus half times our B for this. So from 40 to 50, it is 50 minus 40, which will be 10, times the height is 10. So if we add all these, we are going to get 350 meters. Now, there's a much simpler way. Instead of writing all these, we can just write a simple formula. We can just write a simple formula. Since we know that this is a trapezium, or this shape is a trapezium, so we have distance or area is equal to, for this is a trapezium, so the formula for trapezium is half A plus B times H. Now, how do we determine A and B? A and B are these. So from this point to this point, the parallel lines. So B is A is the shorter distance, and B is the longer distance. The parallel ones, if they are in this, so this one, for example, this one and this one, they are parallel lines. So if the shape is like this, you use this one. This one will be A, this one will be. So in identifying this one, A and B, we need to know the parallel lines. So A, it is actually, so this one, A is going to be 40 minus 20, which will be 20. And the B will be from this point to this point. Yeah, we had a 50 here. So here it will be 50 minus 0, which will be 50. And H, it is from this point to this point, which is 10 minus 0, which will be 10. So this is how we find this. So it is just a matter of plugging in the values. So from this to this, we have our A, which we have found it to be 20 plus. From this to this, we have 50, which is the B, and then we have 10 as the height from this to this. So this one will be half. 50 plus 20, we're going to get 70 times 10. Now, a half of 70 is 35 times 10. So this one, the 5 times 10, it is 350 meters, which is the same answer as this one. So it depends on how you want to take it, but you can either use this way or this way. The answer will be the same. Thank you so much for watching the video, and for this and more, please do not forget to subscribe and turn on the notification bell so that every time I post a video, you are going to be getting notifications. Bye bye.